Hello students, this is a video on the QA topic tests available at Bodhee Prep. Now these tests help you identify which topics you're prepared with. That is, once you do the concepts of a topic, you can take these tests topic wise to understand whether you're able to solve questions in an exam or not. With every test, there is a video which gives you the solutions and a brief analysis of the kind of test that was. So after the test, you refer to the video, and there are more than 200 such topic tests available on the Bodhee Prep Android app. The link for the app is in the description below. So make sure you download the app and make the most of these tests. This video is the third test on the topic polygons that we're discussing. The test in terms of level of difficulty, this one was probably easy to moderate, and therefore in about 15 minutes time, we should be able to get 6 questions net correct out of 8. If we look at the questions, once a regular polygon is drawn on a piece of paper, in how many ways can 5 identical rupee 1 coins? The coins are identical, be placed on the 5 vertices of the pentagon if exactly 1 coin is to be placed on each vertex. So there is a pentagon, 5 sides, 5 coins. We have to place 1 coin on each vertex. In how many ways the placement can be done? Now, one way of placing the coins would be that all the coins touch each other. In this case, the centers of the coins are exactly on the vertices. So this is one way of doing it. The next is I pull back one of the coins. So the other 4 coins touch, but 1 coin does not touch. Now for doing this, I'll have 5 different ways. I can pull back any one of the 5 coins. Or I pull back any 2 coins, for example. The other 3 will be touching each other or will be centered on the vertex. The remaining 2 will not happen. So what I'm saying is, in the first case, all 5 coins out of 5 are centered on the vertex. In the second case, I'm taking out any one. So 4 out of 5, which can be done in 5C4 ways, are centered on the vertex. Or 3 out of 5 are centered on the vertex. Or 2 out of 5 are centered on the vertex. Or any one of the coin is centered on the vertex. The last case will be none of the coins is centered on the vertex. As we move the coins, there will be different arrangements. And therefore, the total number of arrangements will be 5C5, which is 1. 5C4, which will be 5. 10, 10, 5, and 1. Hence, total 32 arrangements are possible. Or there are 5 coins, 1, 2, 3, 4, 5. Each of the coin can have the center on the vertex or not on the vertex. So 2 options are available. For each of the coin, I have 2 options available. So total 2 raised to power 5 or 32 becomes my answer. 2, 4, 8, 16, 32, option B. I will call this question probably a difficult question. It is a little difficult to comprehend what is happening. Once you figure out, maybe especially with the options given, it might be a little easier, but upfront, definitely a difficult question. Each side of a polygon is parallel to either the x-axis or the y-axis. So we draw the 2 y-axis and the x-axis. A polygon is drawn such that it is said to be convex if the internal angle is 90 or concave if the internal angle is 270. Now the most basic polygon will be this one, say a square. All the sides are either parallel to x-axis or y-axis. All the angles here are 90 degrees. So this is a convex polygon. If concave, if I want to make this a concave angle, what I'll have to do is I'll have to remove this and make it a 270-degree angle. So in the first case, the number of sides were 4. Here, if I look at convex angles and concave angles, convex angles were 4, concave were 0. If we remove this side, or if we remove one of the vertices to make a concave angle, something like this is 270. Now, what is the number of convex and concave angles? Convex is 1, 2, 3, 4, and 5. Convex is 5. There is one concave angle. If we further remove another angle to make another concave angle, what will happen? Something like this. Now we have two concave angles, 1 and 2. How many convex angles are there? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So convex is 6, concave is 2. As you can see, the difference always remains 4. If the number of convex corners is 4, if convex corners of the polygon is 25, what will be the number of concave corners? Again, the difference in each case is 4. Difference here should also be 4. So 25 minus 4, 21 becomes my answer. Following the pattern is, I think, the safest way of doing this question. Overall moderate, about 2 minutes to solve. The area of a regular polygon of side 6 is 96. If the perpendicular distance from the center of the side of the polygon is 4, the perpendicular distance from the center to the side of the polygon is also called the in radius. And the area of a polygon is nothing but in radius into semi-perimeter. Here it says area is 96, in radius is 4, and therefore we can say semi-perimeter is 96 by 4, which is 24. And therefore the perimeter of the polygon should be double of the semi-perimeter, that is 2 into 24, which is 48. Each of the side was 6, therefore number of sides into length of side, which is 6, should be the perimeter, or number of sides of the polygon is nothing but 48 by 6, which is 8 becomes my answer. I think easy question because we know this formula now. Area is equal to R into S. Once you put the formula, you get the semi-perimeter, and then it's just one division that is required. About a minute and a half should be good enough to solve. What is this? What is the sum in degrees of all interior angles of a regular polygon of 12 sides? The sum of angles is simply n minus 2 into 180. So 12 minus 2 into 180, which is 1800. Or you can say number of sides into measure of each angle of a regular polygon. This again becomes 180n minus 360 in this case. 180 into 12 minus 360, which is 180 into 2. And therefore 180 into 12 minus 2, which is 10. Or 1800 becomes my answer. Easy question, straight formula, not more than a minute or maximum minute and a half to get this question done. Number of sides of a regular polygon with each exterior angle has measures 45. Exterior angle of a polygon is given by 360 by n, where n is the number of sides. Here this is 45, this is 360. You have to find the value of n. N will simply be 360 by 45, which is 8. And that becomes my answer. The question is done. Basic formula, minute to solve, easy question. External angle of a polygon is 45. External angle of a polygon is given by 360 by n, where n is the number of sides. This is 45, 360 by n, and therefore number of sides of this polygon is 360 by 45, that is 8. We have an octagon that we're talking about. For this, we have to find the number of diagonals. Number of diagonals of a polygon is given by n into n minus 3 by 2, or this can also be written as nc2 minus n. Give you the same expression. Since the value of n was 8 for us, so 8 into 8 minus 3. 8 into 5 by 2, which is 20 becomes my answer. Again, direct formula, two formulas have to be put in, but easy question, about a minute and a half to solve. If the measure of each interior angle of a regular polygon is 150, now interior angle plus exterior angle of a regular polygon should be 180 degree. Interior angle is 150, therefore exterior angle of the same regular polygon can be found out to be 30 degree, 180 minus 150. But exterior angle is nothing but 360 by n, where n is the number of sides. So we can say 360 by n is 30, or n comes out to 360 by 30, which is 12. The polygon that we're talking about here it has 12 sides. What is the number of diagonals? Diagonals in a 12-sided polygon will simply be n into n minus 3 by 2, or 12 into 9 by 2. 54 becomes my answer. Again, two formulas to be put in and solved. Easy question, about a minute and a half to solve. A regular hexagon of side 1 is inscribed in a circle. regular hexagon of side 1 is inscribed in a circle. Hexagon. Something like that, assuming the straight side lines. Each minor arc of the circle is determined by the side of a hexagon is reflected over that side. What is the minor arc? What is the area of the region bounded by this by these 6 reflected arcs? So this arc here is reflected on this side here. Similarly, this arc is reflected here, and so on. So we have to find out the area inside these arcs somewhere here. So basically what we can say is area of the hexagon minus these sides or these arcs. These segments would be a better term. Hexagon has side 1. Since the side of the hexagon is on secant, we can say that area of hexagon will be root 6 into root 3 by 4 a square, which is 1, or 3 root 3 by 2. Also, the longer diagonal of the hexagon, or if we join the center here, this will be the radius as well, and therefore equal to the side. The radius of the circle is also 1. Now, this segment here will be the same, will have the same area of this segment here because it has been reflected. So if we try to find the area of this segment, this will be the angle at the center of a hexagon is 60 degree. So area of the segment will be 60 by 360 into pi r square, radius is 1, minus area of this triangle. This is an equilateral triangle with side 1. So minus root 3 by 4 a square. Each of these segment 1, 2, 3, 4, 5, 6, each of them will have area as pi by 6 minus root 3 by 4. There are six such segments. So the area which is inside these segments will be area of the hexagon minus 6 into area of each segment. So the required area will be 3 root 3 by 2 minus 6 into pi by 6 minus root 3 by 4. This becomes 3 root 3 by 2 minus pi plus 6 root 3 by 2. This will be 6 root 3 by 4. This will be 3, 2. So 3 root 3 by 2 plus 3 root 3 by 2, which will be 3 root 3 minus pi. Option B becomes my answer. Again, because of the calculation, I'm saying it may be a difficult level of question. Will take about 2.5 minutes to solve. But if you look at the overall test, would be an easy to moderate test where I'm trying to find 6 questions because there were quite a few questions which are directly formula based. And for me, my 6 questions would be 2, 3, 4, 5, 6, 7. Which are these? Not counting this question because again, may or may not strike in the exam. This is again a question where we're making a pattern for counting the question. Formula based, formula based, formula based, formula based, and therefore attempting all of these questions. And then finally, the 8th question, the diagram was easy, but if I'm looking at the 6 easier ones, this will not make the cut. And therefore, except the first and the last question, the other 6 questions could be done in about 15 minutes and a 95%.